exponents and perfect squares. We're going to begin our lesson again by writing down our learning goal. Our learning goal today is we will investigate and describe concepts of positive exponents and perfect squares. We're going to take a look at powers first. A power is an expression written in the form of x2, x representing a number, to the nth power, okay, and also representing an integer. An exponent in this example, n, tells how many times the base, in this example which is x, is used as a base. Factor, excuse me, as a factor. Okay, and if you recall, a factor is part of the multiplication problem. It's the two numbers that you're multiplying by each other. For example, in the expression 4 squared, 4 is the base and 2 is the exponent. So the base 4 is used as a factor, there's that word again, 2 times. 4 squared equals 4 times 4. And we know that 4 times 4 gives you an answer of 16. Okay, another example we're going to take a look at is 5 to the 4th power. Okay, and if you look, this expression right here is read verbally as 5 to the 4th power, or it can be read as 5 to the power of 4. Either one of those is appropriate for the situation. In this particular example, the base is 5, and the exponent is 4. Therefore, what this example is showing to us is that we are using 5, which is the base, as a factor, part of a multiplication problem, 4 times. And you can count those, 1, 2, 3, 4. Okay, and if we were to multiply them, we know 5 times 5 is 25. Okay, times 5 again is 125. And then if we were to multiply that times 5 for the 4th time, we know 5 times 5 is 25. 5 times 2 is 10 plus 2. Okay, and 5 times 1 is 5 plus 1 gives us 625. If we're looking at the expression 8 times 8 times 8 times 8 times 8, which is called expanded form, the number 8 is multiplied by itself 5 times. So therefore 8 is the base and 5 is the exponent. The expression written in exponential form, which is the name right here of that form, 8 as the base and 5 as an exponent, is 8 to the 5th power. When evaluating exponents, any base number raised to the 0 power is always equal to 1. Now that might seem kind of counterintuitive, but let's take a look at it in reverse. Let's use the example 2 to the 2nd power. Okay, our base is 2, our exponent is 2. If we do 2 to the 2nd power, our answer is 4. Okay, and I got that answer because I used 2 as a factor twice, and I did 2 times 2, which we know is 4. And let's say I did the same thing, 2 to the 3rd power. Okay, if I were to write that in expanded form, it would be 2 times 2 times 2. And 2 times 2 times 2, 2 times 2 is 4, like we said earlier, times 2 again gives us 8. Okay, let's look at these two, how they're related. 2 to the third power, right here, equals 8. 2 to the second power equals 4. If we went from this product 8, 2 to the third power is 8, and we divided it by 2, then we get that 4. If we did 4 divided by 2, that would give us the solution to 2 to the first power. 2 to the first power equals 2. Let's take it one step further. 2 to the 0 power, by that same logic, if we took that number 2 and we divided it by 2, our solution would be 1. 2 divided by 2 equals 1. And that's the same for every base number that you use. If you divide by that base every time, you will end up with the solution that anything raised to the 0 number, or the 0 power, is always going to equal 1. Okay, now we're going to take a look at perfect squares. When the exponent is 2, the base is said to be squared. A square is a number multiplied by itself. Whole numbers that are squares are called perfect squares. 0 is a perfect square. And if we take a look at the table below, it's a list of a variety of other perfect squares. So let's take a look in the first column, exponential form. The first one, we have 1 squared. If we were to expand that, it would actually mean 1 used as the base, 2 is my exponent, so it's my base used as a factor twice. 1 times 1, and we know the answer to that problem is 1. By the same logic, we're going to do the same thing with 2 squared. 2 squared means 2 times 2, and 2 times 2 equals 4. 3 squared means 3 times 3, and 3 times 3 equals 9. 4 squared means 4 times 4, which equals 16. And the last example, 5 squared means 5 times 5. And the perfect square, or the solution, the product of that multiplication problem, is 25. Here we're going to take one more look at another practice problem. On Thursday, 4 customers came into a bakery. The number of customers on Friday was the square of the number of customers who came on Thursday. And that's a lot of information. So the first thing I want to look at is on Thursday, I had 4 customers. Okay? Important information. Then it says the number of customers on Friday was the square of the number of customers on Thursday. Okay? So that's some information that we already have. We know Thursday, there were 4 people, and on Friday, it says it was square of that number. So if Thursday equals 4, Friday equals 4 squared. Then it continues to say, write the exponential form that represents the number of customers who went to the bakery on Friday. And our final question is how many customers came into the bakery on Friday? Okay, so let's take a look step by step. So let's write the exponential form. We know that the base is going to be 4 because the base is the number of customers who came on Thursday. And we know that that's 4. It's given to us in our word problem. The exponent is 2 because every time we see that square, okay, if you look back up here, when the exponent is 2, the base is said to be squared. So our exponential form is 4 to the power of 2, or 4 squared. And the last thing we need to do is determine the value. 4 times 4 equals 16. Therefore, 4 squared also equals 16. And when we come back to our solution, back to our question of how many customers came into the bakery on Friday, we know that that solution is 16 customers. And that's our notes for today. Please cut these out and glue them into your notebook. And we will continue with a couple of practice problems on the next page. Okay, the first section asks you to write an expanded form. Okay, and the next section asks you to write an exponential form. Okay, it says exponent means exponential as well. We're going to do 2 examples together. The first one, we're going to look at number 1, 6 to the 8th power. I like to identify my base first. My base equals 6. And my exponent equals 8. So what this means is I'm multiplying 6 times itself 8 times. 3, 4, 5, 6, 7, 8. And I plug in that 6. 1, 2, 3, 4, 5, 6, 7, 8. And because it asks you just to rewrite it, that's the solution to that problem. Okay, let's take a look at part B, when it says to rewrite in exponent form. And we're going to take a look at question number 1. Okay, we know that we have 1, 2, 3, 4, 5, 6 factors. Okay, 6 factors are given to us. So that tells me my exponent, correct? 6 tells me it's my exponent because there are 6 factors. And my base is 20 because my factor is 20. Go ahead and try the other 3 problems on your own, and we'll take a look at them together tomorrow.